Hello? Yeah, the video's working. I'm just gonna wait a second because the exam's definitely not started yet. They're probably waffling, so... Alright, first things first. Differentiation table. If y equals e to the power of f brackets x, dy over dx equals f dash x times e to the power of f of x. If y is a to the power of f of x, where a is greater than 0, dy over dx equals f dash x times a f of x times ln a. When y equals ln f of x, dy over dx equals f dash x divided by f of x. The chain rule, dy over dx equals dy over du times du over dx. The product rule, uv dash plus vu dash. The quotient rule, dy over dx equals vu dash minus uv dash over v squared. When y is tan f of x, then dy over dx is f dash x sec squared f of x. If y is sec f of x, then dy over dx equals f dash x sec f of x tan f of x. So sec x tan x. If y equals cosec f of x, then dy over dx equals minus f dash x cosec f of x cot f of x. So that's minus cosec x cot x. If y equals cot x, then dy over dx equals minus cosec squared x. And then 1 plus tan squared theta equals sec squared theta. 1 plus cot squared theta is cosec squared theta. Sine squared theta plus cos squared theta equals 1. Cot theta is the same as writing cos theta over sine theta. Cot theta is 1 over tan theta. Cos theta equals 1 over sec theta. Cosec theta is 1 over sine theta. If y equals tan x, dy over dx equals sec squared x. If y equals cosec x, dy over dx equals minus cosec x cot x. Okay. A curve is convex. If a curve is convex, it means the second derivative is greater than 0. If the curve is concave, the second derivative is less than 0. The arc length for radians equation is L equals r theta. So radius times theta. The equation for a sector in radians is a half times r squared times theta. The equation for arc length in degrees is x over 360 times 2 pi r The area of a sector in degrees is x over 360 times pi r squared. The arithmetic sequence formula is a plus brackets n minus 1 close brackets d. The geometric sequence is a times r to the power of n minus 1. The Sn formula is 1/2 n brackets 2a plus brackets n minus 1 d close brackets. A second formula for Sn is n divided by 2 open brackets a plus l close brackets. For long division, it's quotient plus remainder over the divisor. The circumference of a circle is 2 pi r. I'm just finding out the equation of a cylinder. Okay, the area of a cylinder is the surface area of a cylinder first is 2 pi r squared plus 2 pi rh. And the area of a cylinder is, the volume of a cylinder is pi r squared h. So area is 2 pi r squared plus 2 pi r h, and then volume is pi r squared h. And then the integration formulas. If y equals cos bracket kx, close brackets, the integral is 1 over k times sine kx plus c. Y equals sine kx. The integral is minus 1 over k cos kx plus c. If y equals ln x, this is the differentiation equation. Differentiate ln x, you get x ln x minus x plus c. When you integrate, start again. To integrate sine x, you get minus cos x plus c. Integrate cos x, you get sine x plus c. Integrate sec squared x, you get tan x plus c. Integrate sec x tan x, you get sec x plus c. Integrate cosec x cot x, you get minus cosec x plus c. Integrate cosec squared x, you get minus cot x plus c. If you integrate tan x, you get ln modulus sec x plus c. Integrate cot x, you get ln modulus sin x plus c. Integrate sec x, you get ln modulus sec x plus tan x plus c. If y equals cosec x, the integral is ln modulus cosec x minus cot x plus c. If y equals a to the power of x, integral is 1 over ln a times a to the power of x plus c. If you integrate ln x, you get x ln x minus x plus c. If you have y equals 1 over square root 1 minus x squared, you get the integral of sine to the minus 1x plus c.